Now we begin with a set of presentations from the key mobility work of Smart FM. The broader topic we are addressing today is computing behavioral science and urban mobility, integrated solution to Singapore's mobility challenges. And to address these topics, we have Professor Zhao Jinhua, who's keying in from Boston live. And we have Professor Daniela Roos from Boston as well. So I hand over to you now.
Thank you, Tevin, and good morning, everybody in Singapore and evening in other part of the world. Thank Dr. Lin for the opening remark and inviting us to join today. First of all, may I have a request to all the audience? As much as you can, turn on your video. Video on, audio off. This is mostly for the sake of speakers. You know, talking to a vacuum is an impossible job. We have to simulate some sort of social interaction here. Just a smiley face from some of you will help a lot, right? Thank you so much if you can do that. So throughout human history, human beings invented a fantastic set of technologies that help us move from A to B. While in development economies, there's something called a transport paradox, which says that when income grows, most aspects of life improves, your housing, your clothing, your education, health, etc. But transportation, not necessarily, at least in certain phase of development. Most of you have been to Beijing today, just look like nothing special, probably you all remember, but a few of you may have been to the same city 30 years ago. This is Beijing in 1982. What you can see in the picture is public transit, walking, and cycling. What do we call this picture? Using the modern transportation planning language, we call this sustainable travel, green travel, low carbon travel, healthy travel, active travel, all the beautiful words we use to describe it. However, Beijing as a city strives itself in the past 30 years to get away from this sustainable paradigm and go to in the typical kind of. So here, the question is, now we have these three exciting technology converging upon transportation: electrification, sharing economy, and automation broadly defined. The same question came out, can they fall also into the transportation paradox here, right? So here for today, instead of discussing the technology uncertainty, this is showing the classic trade-off on automation between speed and structure. I try to drive your attention to the system uncertainty here, right? For example, will this be an ownership model or access model? Will it be a single use or shared use? Will the new technology be integrated with public transit or not? Will there be a rational pricing or not, etc.? All these questions, they're not technology per se, but they are as important as defining the overall mobility system. Of course, I was asked to give an impossible job of summarizing 10 years of work by over 100 people within 20 minutes. But it's my honor to have Professor Daniela Roos to join us to co-facing this challenge today, right? So here, before I start, I try to revisit where we started, right? This is one summary by Professor Amedeo Aldoni, who's the first lead PI in the program. He basically summarized the thing into three pillars: natural computing and control, integrated modeling, and the performance assessment. And after that, you have the fundamental capacity, you have the simulation platform on sim mobility led by Moshe Ben Akiva, and then the physics experiment. And you can do it in Singapore and an urban environment. This structure largely, I think, sustained itself into the FM2. And now we have 7 PIs of this current FM program. But here, and of course, we're working with a really fantastic collaborators in Singapore, both universities, institute, agencies, companies, to really co-create all this knowledge and scholarship together. But throughout today's presentation, I really want to ask all the audience to help me think about the following questions. So what are changing in transportation? What are the invariants? And what we can do as human agency here, right? So what's changing, what drives people's mind is typically technology and data, right? Automation, electrification, 5G, Internet of Things, and on the data side, we have ubiquitous sensing, AI, computation, all different things. But today, I really want to emphasize the value part of things, right? What do I mean by that? If you're a transportation professional in the 1980s, right, what you do is very simple, solving congestion problem. That's all it is, right? But today, transportation being framed a much broader set of terms, like as a sustainable problem, as a social justice problem, as this personal identity problem, as urban creativity problem, and as a public health problem, as the COVID-19 is illustrated today. So I'm saying that as transportation professional, it's much more interesting, much more exciting. We have a richer set of objectives that challenging each one of us. And today in the FM2, we are framing the future mobility as kind of an intersection between three things: technology, modeling, optimization, and planning. And more specifically, for each one of them, we have a whole bunch set of really interesting projects here, right? So given the fact that I cannot cover all these projects, so what can we do in 20 minutes, right? So I'll say a few words about the impacts, yeah, and then I really try to say, give people a sense of a style of thinking here, right? Really, I want to emphasize two aspects of it. The first one is the behavioral science thinking that I will try to give a few examples. And the second one is a computational thinking. I will invite Professor Roos to give more examples to elaborate. And the last thing I want to really talk about the knowledge dissemination. After we accumulate the knowledge for 10 years, how do we disseminate to the broad public? So in terms of the impact, right? So we have this trajectory from research to innovation to enterprise. We have all these papers, different prototypes, pilots. And then here I really want to maybe just emphasize the last part on the impact on the enterprise and the human capital, right? Let me start with the human capital part. This is a couple of examples. Song Hong, Malika, and Hai all of this program becomes professors in different educational institute. And this is a group of other people, Hua Yong, Fang, Yang Hong, and Supreto are working at the industry and the foundations, etc. Those are really the most important kind of creation asset that FM is contributing here, right? And now together we based about a survey of 115 alum, about roughly half stayed in Singapore, or 15 at the academic, other industry, and other go around the whole world and contribute in different ways. And then on the entrepreneurship side, there are emotional, mobile market monitor, escape, field hunt. They all come out of the research. Let me give two examples. The emotional, of course, the new autonomy now called emotional, as Dr. Lin was mentioning. Now it's a $4 billion US joint venture, starting from like a lab at FM in the great building there, right? So here, this is really the most significant example where the whole trajectory from the prototype to the particular pilot to a spin-off, then to a really a $4 billion company there, right? That goes through these buggies to a real car and to this wheelchair. And then Ruth now is leading a multi-class, kind of multimodal whole system of autonomous mobility on demand. And the second example is a mobility market monitoring that coming from the future mobility sensing a project there, which developed this interface to really capture data in a much more effective way, which has been utilized across the globe in multiple cities there, right? And another important one is on the freight side. Actually, compared to the passenger travel, we have actually much less understanding of commodity flow and freight flow. And given this e-commerce, Amazon's, Alibaba's, now this become a much more significant portion of urban traffic, and this also contribute to the understanding of this actually the Singapore's first national commodity flow survey there. Right. So that's kind of a very high level summary there. On the research and innovation side, as mentioned, I'm not going to go through the 182 journals. Instead, to give you a flavor of thinking here, right? So I will start with the first set of behavior science thinking here, right? So let me start with Kendall Square. Many of you may be been to MIT. This is kind of dubbed as the most innovative square mile in the world, right? If you count the number of PhDs per capita or Nobel laureates, perhaps this is the highest in the world. But if you look at the travel, right? In the same location, there's about 150 some companies. They share the same location. They share the same access to public transit. But in terms of their commuting car mode share, it ranges as high as 65% to as low as 20%. Again, same location, same public transit access, also similar kind of employee pools in terms of the social demographics. Why there's so much differences in their travel behavior, therefore the energy consumption differences and CO2 emission differences. This is where the behavior intervention make a difference. So how do we change the behavior, particularly kind of this type of behavior? Of course, I use this to illustrate that you cannot understand everything into utility mechanization here, right? throughout the past like about 20, 30 years, we find a lot of behavior deviations away from this rational agent assumption, the perception rationality, preference rationality, and process rationality. And I find a set of deviations, right? And this is where we argue that even though our theories and models mostly speak to the conscious part of the brain, because that's where we, as researchers, have access to. But much of our decision actually made by the subconscious part of the brain. So here we have a list of things that the different instruments can use potentially to change people's behavior. Here, let me just give you some flavor here, right? In terms of time, which is the most fundamental factor influencing travel behavior. I mean, in Newtonian physics, time is linear, one directional absolute. And when I learned in transportation, travel time is wasted, of negative utility, and to be reduced. That's how I learned transportation. That's a classic view by all the transportation professionals. I took this view for a long time until I saw this picture. It's by Delay. They try to reject the notion of rigidity in travel time, right? So here, you can take really different views of interpreting travel time: artist's view, Einstein's view, psychologist's view, transportation view. Here, or more formally in this theory of behavior choice, you'll say that the reality, in order to translate into perception and enter the decision-making process, and the information is the bridge in between, and you can potentially manipulate the information to achieve different behavior changes. I'm using the word manipulate in the value neutral way here. You can do good things or bad things with it, right? Just give an example in London. Most of you maybe been to London, that's what you see, like this famous tube map everywhere, right? But actually, this is the degree to which the map actually distorts reality, right? Map, as a very classic way of transmitting information, actually intentionally distort the information to such a degree for very good purposes. I mean, if you're interested in this, but I should try to say this distortion actually have a significant impact on behavior. If you look at the route choice within the map, within the system, you'll find after controlling for the actual in-vehicle travel time, the map distance is more important in influence people's behavior than the actual in-vehicle travel time. Of course, in the chance to work with the electric vehicle, the auto vehicle that Professor Daniela Rus and Emilio they developed. I'm a behavior scientist. I look at how people use these types of machines, right? You instrument people with the headset, with the heart rate, with new log. I really want to thank Dr. Rose and her team to collaborate on these things for us to really understand how do people perceive this, right? Here, I'm just summarizing this. Autonomous vehicles have multiple aspects. One key aspect, it changes people's perception of travel time. This is the fundamental behavioral reasoning, right? The other one, of course, is on the safety side, right? The changing in perception of time will change in people's travel behavior, change the location of the choice, and fundamentally change urban structure, right? I think that's the most long-term impact that autonomous vehicle could even have. And also today, we have a much more advanced technology with which we can measure those things, physiological and emotional response. I will argue that every business or every organization, the only reason they exist is to change somebody's behavior, right? If you don't do that, that means you have no impact on society. The question is, how do we bring this behavior science knowledge and together with transition technologies and do something useful about it, right? Here we say, bring the two, we can do three different things. We use to shape behavior, to design system, and to reform policies, right? Here, I mean, in the example of this shared autonomous vehicle and its relationship with cities, you can apply this framework and define a whole bunch of different research, like how do people's risk preference influence choice, how do people's pride influence their choice, etc. So here, give you a couple of actual business decisions. For example, in the electric vehicle discussion, the key factor is this range anxiety, right? But here in the behavior sense, you can try to change from an emotional decision where people buy the individual car to a business decision if it's a fleet-based, right? You instead of worry once a year I may have travel from Boston to New York, how do I do it? Instead, you can calculate the exact distribution of the probability of you using it and then solve it as a business decision. Similarly, about the ownership and access or AV adoption, you can have this behavior vocabulary to describe and really understand it. Give a flavor of what I mean by car pride. This is kind of the classic, at least in the US, the social status bias in travel mode. This is not true in many other countries. For example, in Singapore, this is not true, but in the US, it is, right? Here, we try to measure what's the additional value people have beyond the instrumental value of owning the car, which is bringing you from A to B. What's the additional, what's the residual value that. We did a survey actually across 50 countries through an international survey. We found a very interesting thing. If you quantify the notion of car pride and rank it, right, you'll find that the country that have lowest car pride is Japan, France, Australia, Switzerland, Denmark, Germany, etc. Not surprising. The one we have highest car pride are the United Arab Emirates, India, Vietnam, Philippines, etc. In general, you find the developing countries have a high pride and developed countries have a lower car pride, with one exception being the United States. It's a developed country, but has a very high car pride, right? That's why I think there are a lot of exceptionalism of US is nothing surprising here. But why this is important, right? This is why this is important. There's a long debate between attitude and behavior, which influence which. Here we actually find a particular causal pathway here. The car pride actually directly impact people's decision of owning a car. And with a high ownership, it leads to car usage, but the usage itself that reinforce the notion of a car pride, right? This is the first time you can identify a specific causal pathway and lead to a lot of discussion. For example, we're discussing shared mobility a lot here, right? Actually, if the shared mobility really become at scale, it will destroy the sense of a car pride. Because if it's really utility, nobody take pride in I'm using national grid as my energy provider. So there's no pride in this thing. You have to own it to have a pride. So this is really a key thing in terms of the business impact here. Back to MIT, the example, MIT looked at this a couple of decades ago, but MIT look at today, look like this. So what happens here? It's a lot of effort of changing the travel pattern onto the campus here. In 2016, we actually had introduced a new program called Access MIT with many components, which include two key things. One is shift to the daily parking from annual parking. The second one, we give all the staff a free transit pass, right? So what we did is the following. Before the program, we want people to think this way. If I drive, it's free in terms of the marginal cost. And if it's transit, I have to pay $4. But after the program, we want the calculation to be simple. If you drive, it's $10 per parking. And if it's transit, it's free, right? We want to flip the conversation here. And also, we embedded the Charlie card in your MIT ID, so you bring it with you all the time, right? With all those things, we're able to achieve the reduction of drive alone from 30% to 25%, and increase public transit about 5 percentage points. This is from a base that's pretty sustainable already. MIT is doing pretty good. So this 5 percentage point reduction is really a significant change here, right? So we're able to demolish a garage without generating a lot of complaints from the faculty's staff instead of building affordable housing here, right? So those type of behavior changes that you can use to generate many impact. But lastly, I'll just add a few remarks about the real power really comes from you bring the behavior science and the computation together, right? This joint thinking that may be really influential. So here, when you bring the two, what can you do, right? I want to make the following observation of the trend in the mobility industry. I put them into predictive, individualized, being more experimental, and multimodal integration, right? For each of the components, you can think about how behavior science and computation contribute to this, right? And also, give me an example of predictive work, right? Professor Jali, a part of the FMPI, have been working on this traffic prediction. This example for how do you look at the impact rainfall on the traffic speed. And myself and with Professor Koutsopoulos, been working on the transit side. Can you do the individual level prediction? Right. So here, give an example. Based on one travel history, can you predict a person next trip, the travel time, travel origin, destination, right? Like this. It's actually quite complicated to make decision whether you travel, when do you travel, what origin, what destination, right? It turns out that based on certain regularity, you can actually predict this to quite a degree, right? Not 100%, but to a 70 or 80%, right? So the question is, when you can predict at the individual level, then you can personalize the services, make it more effective in terms of the travel demand management, pricing, journey planner, marketing, all these things, right? Here, just give you one analogy here. Most of we've been familiar with Google Classic, right? But Google now is a kind of different service. What's the difference between the two? Google Classic is to give you an answer when you ask it. And Google now is trying to give you the answer before you even ask, right? That's what we mean by predictive services, right? And in translation, there's quite a bit of attempt at this, right? Of course, the other side, it sounds a little bit scary, right? What do you mean by give me an answer before you even ask, right? So therefore they're related with these four trends. They also trigger a set of emerging concerns. For example, the first one I hinted at is privacy, right? There are also cybersecurity, there's climate resilience. So there are a couple of very important topics is coming out as emerging concerns. Here, just to give a flavor of privacy. Particularly look at the location of privacy here, right? There's a different sensitivity as an individual citizen to different things. For example, if somebody comes to ask you your income, ask your social security number, you'll just kick him out. I mean, what are you asking for? And this classic private information. But if somebody says, oh, by the way, we capture your location history, many people are not as sensitive to income as they have to location, right? But actually, it turns out that location, particularly the trajectory, has quite a bit of discriminatory power here, right? There's research illustrating just using 4 data points, you can identify about to 90% of those population people. So the travel history can say a lot about your socioeconomics, about your characteristics, right? So here, how do we kind of help inform the public to be aware of this locational privacy? And then how do you then, our research try to quantify what's the price of such privacy here, right? There's a lot of new technology. Each one of them have these potential privacy concerns. The trade-off is between the privacy versus utility. We want to give a more precise, quantifiable notion of the value of the privacy here, right? So for now, I just maybe mention this. We introduce a couple of different ways to mask the specific location, and then to say that in order to protect this location privacy through whatever distinguishable or the other technology, you have to sacrifice in 2 possible ways. One is in terms of the overall system efficiency. The other one is in terms of the quality of the service, right? But whichever they are, you have to pay a specific price. Here, we try to mention the point that instead of treating privacy as a barrier, privacy can be used as a business differentiator. Today, in US at least, between Uber and the Lyft, there's no customer loyalty at all, right? You a cheaper of privacy, they actually can potentially differentiate themselves, right? So here, I will skip the cybersecurity one, there are a lot of contribution. Lastly, is to say a few words about the behaviors perceptive of machine learning, only at the conceptual level. There's quite a debate between this domain-specific model and machine learning model. This is true across the board, right? In transportation, energy, health, all have this question. Then each has its kind of conventional notion of machine learning better at prediction, domain-specific model better at interpretation, robustness. But all these conventional wisdom being challenged these days. So one thing is can we integrate the two and bring out the best out of this? This example in the travel behavior modeling field, where you have to the left side is a pure DNN model. You potentially have a high prediction, but it's very hard to interpret any of this, right? To the right, you have a very clean and a nice utility map, but you may not be able to reflect the nuances of the travel behavior. Well, if you bring the two together, that's where it's an interesting trade-off. It follows the general patterns of the utility maximization, but add the richness to the local variations there, right? So I will skip this part. Lastly, I'll just say a few words. The behavior science, the godfather of this field is Daniel Kahneman on the Thinking Fast and Slow. This is a book. I mentioned the 2 systems, system 1 and system 2. There's actually an interesting mapping between the AI development versus system 2 and system 1, starting more system 2 thinking in the early stage to today's, the DNA mostly is system 1 thinking type, and more towards a integrated system 1 and system 2 together as the innovation